even a name. But I went to Tita Mirla and I told Tita Mirla, who is this gentleman, a tall gentleman, who always keeps on coming to Tita Ludi after his arrival from Vietnam, and said that's Mr. Tan. Yeah, you recall him? Not anymore. Anyway, anyway, so Tita Ludi has been helping these scholars to earn their MS and PhD degrees. So she has been involved in various projects in her 30 years here at IRRI. She worked on the efficiency of modified forms of urea, as you can see in the PowerPoint with the late John Flynn, and on wheat system and economic evaluation of green manure in rice crops with Mubarak Ali. She worked the longest with social funding, dealing with the economics of direct seeding, upland rice farming, rain-fed rice production system. At present, she is under the supervision of Takashi Yamano, working on the TRIPSA project. And the next phase of the TRIPSA project will be with the youngest team at SSD, the market research team, working directly with Alice Laborte. Yeah, as I recall, TRIPSA was initiated by Social Funding, and when Social left IRRI in 2011, she took charge of the project. She analyzed the data, wrote the report, and presented the final results in Italy earlier this year. And now she volunteered to give a seminar here at IRRI, maybe to share also the results to us. Today, she will be sharing with us some of the results of the Project TRIPSA, which used the method of expert opinion, an alternative to household survey in obtaining estimate of varietal adoption levels. Ladies and gentlemen, let's all welcome Tita Ludi.
Can you hear me?
Yes.
Yes. Okay. Good morning, everyone. As Joyce mentioned, I will be sharing with you some of the results of the TRIPSA project, which use expert opinion method as an alternative to household surveys in obtaining estimates of varietal adoption levels. Now, TRIPSA stands for Tracking Improved Varieties in South Asia. Now, since this is the first presentation, and I guess the last, on TRIPSA, I'd like to give a brief background of the project. It is well known that research on crop genetic improvement led to the development of improved varieties, more popularly known as the modern varieties. And widespread adoption of modern varieties led to the Green Revolution in the 70s in Asia, which is characterized by a rapid increase in food production, which contributed to the decline in poverty directly through increases in farmers' incomes and through a long-term decline in the prices of food grains. Despite the importance of crop genetic improvement, the recent decreasing growth in rice research funds resulted to a stagnation in crop genetic improvement. Hence, there is a need to know what is happening to varietal change as a result of crop improvement. The magnitude of planted area is an important determinant in the size of economic benefits and ex-post impact assessments of agricultural technologies. However, information on recent vintages of improved varieties replacing earlier vintages, the sources of seeds and varietal information, and the rate of seed replacement are important but are limited if not unavailable. Information such as the uptake and impact of new varieties is valuable for donors in maintaining and even increasing investment in genetic research. Information on the nature of dynamism in varietal adoption and turnover are important for allocating scarce research resources to aspects that are likely to increase impacts. Information on the adoption and cultivar use helps in deciding on relative resource allocation for commodities and specific lines of research. Thus, the aim of the project is to lay the groundwork for tracking not only the successes but also the failures of crop improvement investments and for understanding the impact of those investments on poverty, nutrition, and food security through the construction of a routine system of monitoring varietal adoption. Now, the project has two objectives. Objective 1 is to attain a wider understanding of key aspects of performance of crop genetic improvement in South Asia. Activities under Objective 1 include compiling varietal releases up to 2010, conducting survey on rice scientists' time allocation in genetic improvement, and piloting a method of obtaining quick and clean estimates of varietal adoption through expert elicitation. Now, Objective 2 is to gain a deeper understanding of the adoption and diffusion of new varieties. And activities under this objective include focus group discussions on varietal adoption at the community level and farm household surveys, mainly on varietal adoption. Now, we call this a project of twos. This is a 2-year project funded by BMGF with 2 objectives and a partnership between 2 CG centers, IRRI and IRRI-Social, covering 2 types of crop: wetland crop rice and dryland crops sorghum, pearl millet, chickpea, pigeon pea, and groundnut. The dryland component is being managed by IRRI-Social and has implemented it in India, whereas the rice component is managed by IRRI and has implemented it in 5 countries: India, Bangladesh, Nepal, Sri Lanka, and Bhutan. And the project covered the 3 eastern states of India, Chhattisgarh, West Bengal, and Odisha. Now, this report will be on the activities of the rice component managed by IRRI, focusing mainly on the expert opinion method and some adoption patterns derived from the study. Now, the IRRI collaborated with 8 institutions for this project. And the project covered countries as small as Bhutan with only 23,000 hectares of rice, and a country as big as India with almost 43 million hectares of rice. The 3 eastern Indian states covered under the project, Chhattisgarh, West Bengal, and Odisha, cover almost 13 million hectares of rice, which is 30% of total rice area in India. Now, this table briefly summarizes what we have in our varietal database. It contains varieties released in the 5 countries. The database also contains varieties released in the whole of India as published by the Directorate of Rice Research, which contains 946 varieties and 58 denotified varieties for a total of 1,004 varieties released since 1933. This database contains pure line selections of land races, and thus land races are also classified as, these pure line selections of land races are also classified as modern varieties, where land races which were found to perform well in farmers' fields had to be officially released for the variety to get into the seed supply chain, because in India, seed production is managed by the government. This database also contains hybrids, but it does not contain hybrids developed by the private sector. Notice that India has the largest outflow of modern varieties. Neighboring countries benefit from India's rice research through the movement of some of these varieties across borders. This international spillover may be the reason why smaller countries have not invested much on their own rice research and are therefore releasing varieties at a lower rate. Aside from the movement of varieties across borders, neighboring countries such as Bangladesh, Nepal, and Bhutan benefit from the rice research of other countries by officially releasing varieties from these countries. They do not only officially release varieties from South Asian countries, but also varieties developed in Southeast Asian countries and East Asian countries. In addition, we see more than 20% of the varieties released in these 3 countries were developed by IRRI. Now, this table shows the use of IRRI materials in the varieties developed in the 5 countries. Note that this is not based on a complete genealogy. The use of IRRI material was measured only up to the parent stage. We see in the table that modern varieties released by IRRI developed by IRRI were not only officially released in the collaborating countries, but were also used as parent material for varietal improvement. And overall, IRRI varieties were used in more than 30% of the varieties released in the collaborating countries except in Sri Lanka. Now, the method of expert opinion was piloted in this project as an alternative to household survey in obtaining quick and clean estimates of varietal adoption levels. Expert elicitations were conducted using a modified Delphi method, which involved several rounds of elicitations from a panel of experts until a consensus is attained. Now, this slide shows the form used for the elicitation process. Experts were first asked to provide their perception in the percentage area covered by all traditional varieties and percentage area under all modern varieties. Then they were asked to list down the top 10 modern varieties according to area coverage and provide their perception in the percentage area grown to each variety. All other varieties grown in small areas were combined, were grouped and classified under the other modern varieties and given the residual share in area. Although the expert opinion method is cost efficient and time saving compared to the household survey, data collection is limited to area coverage by the different modern varieties. Now, a 6-step process was used in the initial elicitation done during the training conducted by a consultant. Actually, the consultant was the project coordinator of the DIVA project. The TRIPSA is a South Asian counterpart of the DIVA project, which is diffusion and impact of improved varieties in Africa. But succeeding elicitations used only 3 to 4 steps, as other steps were deemed not necessary. Now, for the success of the elicitation process, the role of the facilitator is critical in balancing participation among panel members, especially when senior experts begin to dominate the discussion, and in assisting the group in resolving differences among panel members in the event that a consensus cannot be reached. Now, the ideal composition of the expert panel is one that consists of breeders, socioeconomists, agricultural extension officers, seed grain traders, and in cases where sub-national level elicitations will be done, seed producers and farmer groups may be represented in the panel. Note that the identification of research persons with expertise on varietal adoption is important. Now, expert elicitation was conducted at the state level whenever possible. There are instances, however, where state level elicitations could not be done, state and national level elicitations. Take the case of West Bengal, because a lot of changes were happening in the rice sector in West Bengal. It was difficult. Thank you. It was difficult to identify experts who could provide an overall picture of the varietal adoption for the whole state of West Bengal. Thus, only district level elicitations could be done. Another reason for conducting a district level elicitation was to capture spatial variability due to differences in agroclimatic conditions. Now, estimates provided by experts were validated using household survey and community survey. Thus, the objective of the household survey is to obtain information on varietal adoption for use in validating results of the expert elicitation and collect information on adoption patterns at the farm level. The objective of the community survey is to obtain background information on varietal adoption and disadoption and to counter-check results of the household survey. And for this reason, nationally representative sample surveys were conducted, as opposed to conducting an intensive survey covering specific areas. The project conducted extensive surveys covering a wider area, but focusing only on varietal adoption. And multi-stage sampling was used with stratification on selected districts. And 2 to 6 blocks were selected per district, 1 to 6 villages per block, 2 to 10 household per village, for a total of 675 villages for the community survey and almost 7,300 households for the household survey. Weighted estimates at the country or state level were obtained using district-wise rice area as weights. Note that there was no survey conducted in Sri Lanka because data on varietal adoption collected by the government in relation to their fertilizer subsidy was used to validate results. And also no community survey was conducted in Bhutan because Bhutan was so small that data from household survey was sufficient for the validation. Okay. The next section of the presentation will focus on the results of the expert elicitation process. In the comparison of results, the household survey data was used as the benchmark. This graph shows the estimates of area grown to all modern varieties derived from the expert elicitation, the blue bars, and from the household survey, the red bars. A close correspondence is observed between the two methods, with some degree of underestimation and overestimation. In Sri Lanka, we see a very high correspondence between the two methods. That is because experts invited to the elicitation meetings had access to the reports on the varietal adoption in relation to the fertilizer subsidy. Now, we see low correspondence in Bhutan. That is because one of the agroecological zones was inadequately represented in the household survey. But overall, estimates correspond well within 10 percentage points of over and underestimation. Now this table shows the comparison of cultivar-specific attachment estimates from the two methods. The measures used were mean absolute error and correlation coefficient. Mean absolute error, as the name implies, is the average of the absolute difference of estimates between the two methods. It is expressed in percentage points. Again, we observed high correspondence in Sri Lanka for the same reason that experts had access to the fertilizer subsidy reports. But we observed a not so high correspondence in West Bengal. Well, probably in West Bengal, we need further investigation because experts were giving high estimates of the 2000 release Satabdi and the low estimates of area covered by Lalat and Gontrabidha. We also observed not so high correspondence in Nepal, which could be due to problems in variety names. Farmers in the household survey were reporting different versions of Masuli, like Hule Masuri, Kanchi Masuri, Sawa Masuri, which were not in our varietal release database. This is probably the case where DNA fingerprinting would be useful to properly identify these varieties, because these varieties, when combined, cover 20% of the MV area in Nepal. In other sites, good correspondence is observed in the estimates between the two methods, with an average MAE of 2.4% and an average correlation coefficient of 0.95. Now, a comparison of estimates was done across, comparison of estimates by variety was done across experts to look into how well the method works. And for illustration, the case of Odisha was used. Expert estimates here are averages of the estimates provided by 7 experts invited to the state level elicitations. And each estimate was compared with estimates derived from household survey. Now, the measure used here is SMAPE, which is symmetric mean absolute percentage error. Compared to MAE, which is simply the average of absolute differences, SMAPE expresses the absolute difference as a percentage of the sum of the two estimates. And SMAPE ranges from 0% to 100%. A value close to 0 indicates high correspondence, while a value close to 100 indicates low correspondence. It was hypothesized that error was inversely related to area coverage, indicating that widely grown modern varieties have lesser margin of error than modern varieties grown in smaller areas. Well, this table validates this hypothesis as experts were able to estimate area grown to dominant varieties Swarna, Puja, and TU1001 and Lilat with low SMAPEs and estimated varieties grown in small areas with large SMAPEs. Now, a comparison of estimates by state of release was likewise done to assess for bias in the estimates provided by the experts. The comparison was done in Chhattisgarh, where varietal improvement started late and varieties developed in other states of India are more commonly grown. The table shows that experts in Chhattisgarh tend to be biased upwards in favor of modern varieties developed locally. As you see here, the overestimated area grown to Mahamaya, Karma-Masuri, Purnima, and Dataswari, which are all developed in Chhattisgarh. And they tend to underestimate area grown to varieties developed in Andhra Pradesh and those released by CVRC, the Central Variety Release Committee of India, except for IR64. This scientist bias may be common among breeders, and to counteract this, field-oriented experts like extension officers must be included in the panel. Now, adoption of modern varieties vary by agroecologies. And field hydrology and climatic conditions are related to agroecological classifications. And in this case, modern variety adoption was compared in India by land type, in Nepal by ecosystem, in Bangladesh by season, and in Bhutan by altitude zone. We see low adoption in the mid-altitude zone in Bhutan, mainly because this altitude zone was inadequately represented in the household survey. But if we were to compare adoption in the low altitude zone in Bhutan with the high altitude zone, this low modern variety adoption in the low altitude zone could be due to the lack of modern varieties recommended for this domain relative to the size of the domain. We also see low adoption in the lowlands of West Bengal and Odisha. Now, a closer look at the varieties grown by agroecology show that farmers grow different sets of varieties by agroecology. Consider the case of Bhutan, where we see a clear delineation of varieties grown by altitude zone. We also see farmers growing different sets of varieties in the uplands of West Bengal and Odisha and compared to the lowlands of the same state. Well, farmers in the uplands prefer to grow Lalat in West Bengal and Kandaviri in Odisha because of the short duration characteristic of the variety, which allows the crop to be harvested early, thereby reducing the chances of exposure to drought when the rains cease. Now, these complexities must be considered when conducting expert elicitation. Another point to consider is the spatial variability in modern variety adoption. This graph shows modern variety adoption across districts in Odisha where data of this type is available. The red line is the state-level average. Several factors cause spatial variability across districts. Consider the case of Ganjam with high adoption and Sundergarh with low adoption. In Ganjam, more than 7% of the area is irrigated, whereas Sundargarh has large upland areas which are often exposed to drought. This variability, spatial variability can be captured by conducting elicitations at the subnational level. Now, a comparison of state-level elicitations and district-level elicitations were done in sites where both levels were conducted, like in Odisha and in Chhattisgarh. Results show minimal gains in correspondence is observed in district-level expert elicitation, which indicates that experts invited to the state-level meetings, state-level elicitation meetings, were aware of varietal adoption at the district level. Now, to recap on some of the results of the expert elicitation process, there is close correspondence between expert estimates and household survey estimates on area grown to all modern varieties. Cultivar-specific estimates provided by experts closely match those from the household survey. Experts were able to provide reliable estimates of area under dominant varieties, and a panel composed of experts with diverse backgrounds is essential for reducing systematic bias in the estimates. And in areas with high environmental variability, it is important to conduct expert elicitation at the district level. And estimates obtained through national level elicitations are consistent with district level elicitations, provided resource persons with adequate expertise are selected in the panel. Now, the next section of the presentation will focus on the patterns in varietal adoption derived from the community and the household survey. Varietal turnover here will be characterized in terms of average varietal age and average adoption lag. Average varietal age here is in reference to 2010. And average varietal age in Bhutan is 14 years, whereas in other sites, average varietal age ranged from 19 to 23 years, indicating that in 2010, varieties cultivated are those released in the late 80s and early 90s. Now, adoption lag is the age of the variety when it was first adopted by the farmers. It is a time lag from the year of release to the year of adoption. It may also be interpreted as the number of years it takes a farmer to adopt a new variety. Well, some farmers would adopt a variety at an early stage and others takes a longer time to adopt a new variety. This adoption lag is the average across all varieties and across all farmers. So except in Bhutan, where adoption lag is 7 years, adoption lag in other sites range from 12 to 14 years. This leads us to the issue if this low varietal turnover is a result of problems with the seed system and information dissemination. A closer look at the proportion of modern varieties by year of release show that modern varieties released before 2000, the green bars and the blue bars, cover more than 60% of the area. And also, except in Chhattisgarh, less than 20% of the modern variety area is grown to modern varieties released in 2000 and after. With an adoption lag of 14 years, with an average adoption lag of 14 years, this indicates that these varieties with varietal age 10 years or less, are at the early stage of adoption. Well, experts are able to we're able to identify the top 4 most popular varieties grown by the farmers. And a closer look at these varieties show that 2 to 3 modern varieties account for a large area under modern varieties, most of which are more than 10 years old. Now, farmers invited to the focus group discussions conducted at the community level could easily provide information on varieties disadopted and varieties grown in its place. This slide shows the disadoption pattern derived from these discussions. Let me briefly describe what we have here. The first column is the distribution by year of release of the disadapted variety. The second column is the distribution by year of release of the replacement variety. The first pair of columns is for Chhattisgarh, the next pair is for West Bengal, and then for Odisha, Bangladesh, and Nepal. We don't have it for Sri Lanka and Bhutan because community surveys were not conducted in these two countries. Now at the bottom, you see varietal age of first the disadapted variety and then the replacement variety for each country and state. Now results show that old varieties, that is varieties released before 1980, the green bars are being replaced with newer varieties, the blue bars and the red bars. We also see that varieties released after 2000 is becoming more popular in all cases. This indicates a replacement of old generation varieties with new generation varieties, with varieties released in 1980 to 1999 dominating the replacement. These changes resulted to a lower varietal age of the replacement varieties. Note also that in Nepal and also in Bangladesh, modern varieties are even being replaced with traditional varieties. But also, the reduction in the lower varietal age in Odisha is not obvious in the graph. That is because most of the replacement varieties were those released in the mid and the late 90s. Now, an investigation of the adoption behavior of growers of mega varieties Swarna was done in Odisha, where 58% of the farmers grow the 31-year-old variety in 42% of their rice farm, where farmers grow more than one variety. And in this case, Swarna growers grow two other varieties aside from Swarna. This indicates that mega varieties are not grown in large areas by few farmers, but are grown in substantial portions of the farm by many farmers with other varieties in between fields. Also, we see that farmers adopted Swarna 20 years after its release in 1979, but are adopting other varieties 9 years after its release, although these varieties are now 17 years old. This indicates that Swarna growers do try out newer releases, but the question is why they continue to grow 17-year-old varieties. This brings us back to the issue on awareness of new releases and availability of seeds of these new releases. Or could this be due to a lack of high-performing varieties that could potentially replace Swarna? This picture was also observed in West Bengal, where Swarna remains to be the dominant variety at 31% area coverage. I think 34% area coverage. Now, another thing I did was to look into what kind of changes we may observe if we were to track varietal change after 3 years. And this was done using data on Harvest Plus survey conducted in 2008 in Odisha and the TRIPSA survey conducted in 2011. Now, data collected for the Harvest Plus survey are in reference to farm practices in 2007, and data collected for the TRIPSA survey were in reference to farm practices in 2010. Well, the same collaborator conducted both surveys with more than 6,000 households for the Harvest Plus survey and more than 3,000 households for the TRIPSA survey. Well, we may say that the TRIPSA survey is a subset of the Harvest Plus survey only in terms of locations, because households were selected from a subset of the blocks and villages included in the Harvest Plus survey. So this is not the case of the 2008 respondents revisited in 2011, although some households were present in both surveys. Now, results show a decline in the cultivation of Swarna from 41% in 2007 to 31% in 2010. We also see old varieties, a decline in the old varieties, and an expansion in the newer varieties. Combining old varieties and the new varieties show that area coverage of varieties with average varietal age of 24 went down from 60% to 47%. And we see an expansion in the area coverage of varieties with average varietal age of 9 from 18% to 35%. We even see the slight expansion in the cultivation of 2000 releases MTU 1001 and Sorala, and the cultivation of varieties released in 2005, Pratiksha and Naveen, which were not previously cultivated. We also see a slight expansion in the cultivation of hybrids in a span of 3 years. And to summarize, to characterize the varietal adaptation derived from the study, 2 to 3 dominant varieties cover large areas under modern varieties. Old modern varieties dominate with less than 20% of modern variety area grown to modern varieties released in 2000 and 2010. Farmers adopt new modern varieties more than 10 years after its official release. And mega varieties are not grown in large areas by few farmers, but are grown in a substantial portion of the farm by many farmers. And to summarize, expert elicitation is an effective tool for a quick assessment of cultivar-specific adoption, although data collected is limited to area coverage of different varieties. Community interviews is a cost-efficient method for specific case studies of adoption, disadoption, and is useful in providing information needed for cost-checking of household survey. I did not show it, but estimates derived from community surveys were very close with estimates derived from the household survey. And widely adopted modern varieties are generally those released in 1980 to 1999 with limited adoption of newly released varieties. And regularly assessing varietal adoption every 3 or maybe 5 years through expert elicitation will be useful in tracking varietal change.
Thank you, Tita Lizzie. Any questions? Who would like to ask questions?
You're supposed to answer the questions.
She said.
I'm supposed to answer. I have a clarification. I think it's a very excellent presentation and very comprehensive. I think you have to be congratulated after Susan left, you took it over and kind of led this project from the front. Thank you for that. And I just have to also mention that these findings are widely used by the foundation and many other projects. I have seen a lot of people using some of the findings from TIPSA. So that says the high profile, the high profility of the project or whatever. My question goes to your sample size. I think it goes back to Odisha. You covered 4 countries and 3 states from India. And the sample size for Odisha is nearly half of your total sample. Okay. I don't think Odisha population density is that high. It's one of the less populated state in India in terms of the number of rice farmers. My question is, what prompted you to go for 3,000 more sample of farmers household survey in Odisha, whereas comparatively, is that a deliberate or is something happened because Debadatta wanted to just cover?
Yes, we could not control him.
Yeah, okay.
We tried to bring it down to 1,000, but he insisted on doing it, but did not ask for additional funds. So we said, all right, go ahead. But the problem is, it added more workload on me because I had to check 3,000 instead of only 1,000.
But that actually distorted your sampling scheme. You had a sampling scheme that was consistent across states or across country. Now it really doesn't fall. That thing you should take it out. Because now you have a lot more coverage in the state of Odisha. You probably cover a lot more blocks per district, a lot more villages per block to get that 3,000 samples.
Yes, but results were not so different from the other. If the results probably for Odisha was stand out, maybe we have to consider that. But the results are almost the same as the other sites.
So the other thing is your comparison for Odisha, harvest plus Tripsa. One thing was very interesting for me is that Sona, which is a dominant variety, is declining rapidly. In 2-3 seasons, 10% decline.
Yes.
In Sona, it's been going to Pratiksa and Puja
Puja.
and couple of, which is correct, which is actually very consistent with what you see happening at the field level. My question is, if you have to project 5 years down the road or 10 years down the road, you think do you believe that there will not be any dominant varieties anymore? There will be, lot many more MBs with 5-10% area, and not like Sona was 40% before. We may not have that in the future. Because I see kind of that Sona is losing to many different varieties. That Sona share is going to Pratiksa, Puja, and many other varieties. So 5-10 years down the road, we might have 10 varieties occupying 5 to 10%.
Probably, I cannot say. It's possible because we are coming up with newer varieties, more focused on these ecosystems. So
But I think overall, I think this is very fascinating findings and very useful for a lot of activities. Thank you.
Any other question? I think this is not working. Anyway, just log out. No need, yeah.
Okay, thank you, Ludi, for this interesting presentation. I'm just curious about the expert opinion approach. How do you select those experts? What are the criteria? What are the criteria in selecting those experts?
yeah, we left it for the collaborators to select the experts. Basically, we have breeders who are aware of they more or less know who are the active breeders familiar with the varietal adoption. We have socioeconomy to work on, like in Odisha, we had a person in charge of the cost of cultivation study, so he was aware of the varietal adoption in the whole of Odisha. So we left it to the collaborators to identify. But actually, this is state level elicitations were conducted by Dr. Kandi before he left. Because the collaborators were complaining that experts will not come to a meeting unless somebody big calls for the meeting. So he had to go there. This is one disadvantage of the expert elicitation method. So Dr. Kandi had to go to these different countries to conduct the state level elicitations. And then because the collaborators were saying varietal adoptions is different in different districts, so they opted to go for district level elicitations.
Any other questions? Yeah. Those who participated in the elicitation process, were they given incentives?
No incentive. We just paid for their travel because some were coming from far places. We just provide them travel allowance, but otherwise no other incentive. And lunch. But they were happy to participate because initially, before we started, they were afraid they would not be able to provide good estimates because some are familiar with varietal adoption in other agroecologies and are not familiar in all other places. But after the elicitation, after the meeting, they were happy to learn. They said they learned from the meeting because of the discussion.
Any has a question?
Hi, Dean. Thank you for making us proud. Yeah, you did a very good job. So congratulations. I have two questions. First is on expert elicitation. In your experience from those countries, what would you suggest to do if you are faced with experts who, as you already mentioned in your presentation, who dominates the discussion? How difficult is that, and what would you suggest to do if this is, say for example, this methodology is repeated by somebody else in the division? That's first. And then second, picking up on your reply to Dr. Mohanty's question, where you said that as breeders develop varieties that are more sensitive to the ecosystem, for greater adoption. I observed that in all the countries, except for Bangladesh, the released varieties, the estimates are by ecosystem, upland, lowland, medium, highland, like that. But for Bangladesh, it's by season. Does it mean that agroecosystem is not that important for Bangladesh?
No, during our discussion with the collaborators in Bangladesh, they were saying that recommendation of varieties is by season, and adoption is also by season. Farmers select specific varieties for specific seasons. That's why we went for, even in the elicitation process, instead of estimating, one of the steps in the elicitation process is to estimate varietal adoption by ecosystem or agroecology. They went for by season.
Any special reason?
Huh?
Any special reason?
Sorry. Even in the data we see different sets of varieties by season. She has another.
Another question.
What was the other
The
question?
first question.
In the facilitator, if we were to do this, I think training has to be done in how to handle these kinds of things. It was, sorry to say, but it was Dr. Pandey who did the elicitations. He was the facilitator in all of the state level elicitations. And so he was kind of discussing with them whenever you see them, because I was not familiar with the language. And so Dr. Pandey could speak Hindi, so he knows when things are getting hot.
Dr. Barker?
Is there anything happening on the adoption of the sub-1 gene?
Yeah, we looked at that, but very low adoption. As you saw in one of the slides, sub-4 and sub-1 is at, where was that? Yeah.
So the-
4 and sub-1 is at 0.3% based on the household survey. I just think this method, the MGF wants to set up a system of monitoring varietal adoption. Maybe they want to see, because one of the goals of the Strasser project is to reach certain number of farmers, certain area, and probably they want a system in place with monitoring the varietal adoption of maybe the Strasser varieties, the GSR varieties.
Yeah, because 2007, I don't think Swarna Sabhan even was officially released in Odisha.
It was released in 2009. So it's
2009.
2010.
10, that's what I'm saying, so
very
it's pretty,
early stage, but the adoption I think is quite high considering
That's what
the
I'm saying.
time it was
so how did even they could get that much of adoption when it was not even released? Because
This is probably slightly biased because that is working on the Strasser project phase 1, and he included the site where the village we went to. He included that, purposely included that village in the sample because he wanted to see how Swarna Sub-1 would fare compared to the other varieties.
yeah, because I hear that as of now, maybe 25,000 farmers have adopted Swarna Sabhan, so which is 2013 already. So I have another question.
span of 2 years and state.
No, I'm not giving you hard time. I like what you have done. I'm just clarifying for this. My question is, we already have published sources in India by state, which actually publishes the MB adoption
I
and
see.
adoption by different varieties. You know, that's already
By
there.
different varieties?
Yeah, Swarna, other things you will find from cost of cultivation
Oh.
survey. They have they publish by state. What I'm saying is when you bring in the expert, they are influenced by the published sources available in the country.
Yeah.
Okay.
Mhm.
They basically tell you the numbers which is close to the published sources. Okay.
Then
So what I'm saying is it worth bringing those experts instead go back and look at what's available in the national system and use that against the survey instead of bringing those experts.
Yes. But the cost of cultivation is only done in India, and for other countries it is not. So, and also this is why we include extension officers. It's important we have extension officers because extension officers do not necessarily have access to these reports. So if we include during the discussion, if we include breeders, extension officers, seed producers, that is where the discussion will, it will also verify whether the published results are actually what's happening in the field.
Any other just
Last question.
Would you recommend for the division to have this a training on expert elicitation as part of a retooling for the staff?
No, but this expert elicitation is only useful for tracking varietal change. It is not a substitute for household survey. It only collects data on area coverage for the different varieties, actually the dominant varieties. It will not provide you information on adoption patterns. So unless an expert elicitation should actually be done by the NARES, by the country itself. So if this turns out to be useful, it should be institutionalized and maybe refine the method, refine the procedures before it's institutionalized and determine the adequate time interval for the elicitation to be conducted. Because conducting it every year will probably not give you good results because especially if you'll be inviting the same experts every year. So this should be done by the locals, not by you.
are there other?
I have a question regarding the correlation analysis. Because I just clarify, each expert represents what? Village or block or what?
Which one?
Each expert or each breeder or each represent what village?
But no, we have state level elicitations and district level
And you have
elicitations.
the and you have household. So how did you perform correlation analysis? Did you take the average of the households?
No, the estimates reported are weighted estimates, aggregated district level estimates. I use district-wise rice area as weights because some districts would have bigger rice area than others, so we need to correct that one.
I know about okay.
Okay.
Because you have done some analysis of the different characteristics of the varieties adapted, remember the paper of Neil? Would it be nice if you could do the same for this because you already have the information, the different varieties, and that will be a very good input to breeders.
Actually, I was going to talk to Ruby afterwards about that. And also there's a lot of information there like the spatial variability across districts that they looked at. It would be good to see why there is spatial variation. So what explains that? Because they have a lot of data already. Maybe we can link that up with other existing information like other surveys that have been conducted already and try to find out the why. Because I think the study is more of like the extent of the adoption, but not really focusing on why this is happening or why there is replacement and how come it takes so long for a new variety to be adopted by a farmer or a new variety, an old variety to be replaced. So I think that is something that we should look into. And Ludi is joining the group, so I think that would be a very good collaboration project to look into.
Guys, so any other questions? No more? Okay, so let's all thank Tita Ludi for a very good